So, Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a very good day. So, we meet again in this video. So, actually, in this video, I would like to show how a simple set of tools that can be used to analyze a big data set to fulfill a specific objective in a short time, which I think is very important because it can help to increase the productivity of the day. So, this is the scenario given for this sharing. Basically, I have data from daily basis data from 4th of February 2010 up until 30th of June 2020. And I need to perform all these four tasks given to me. All right. The first is to determine the number of vessels involved in the database by year. So this is where I'm going to show you how to use a pie chart and Pareto chart and have years as one of the categorical variables to determine the total and average of distance coverage and average of actual speed by each vessels in the specific year. Okay, this is more on the descriptive statistic, whereas the first one is on the data classification, okay, which is to be specific more on the chronological classification. And the third one is involving the inferential statistic, okay, where I need to prove whether or not the vessels covering the same distance average and also the speed average. And last but not least is to check whether the operation of each of the vessels in terms of the speed is in control or out of control, okay, comparing to the audit speed of fixed average of 19 with the standard deviation of 2. All right. So the data given to me in Excel file, so I need to open up, extract the Excel data from the Excel file into Minitab. Okay, so this is the data. All right, so for the first task, okay, as a preparation, I need to actually extract the year from date column and save it in the C6. Okay, so the reason being is because if you look back at the first task is to determine the number of vessels involved in the database by year. All right, so this can easily be done by data, date/time, extract to numeric. So the information that I would like to extract is from the date column. I need to store it in year column, and the only info that I need is the year. All right, so altogether here I have 3,800 data. So extracting the year from these 3,800 rows of data doesn't take you long. Just within a second you can have everything. So when this is done, then okay, to answer the first question, actually I have several choices. I can go for stat tables, descriptive statistic. Let's say I select a vessel for the rows and then column year. If I click OK here, it will give some sort of table, okay, in numeric form. Okay, for example, in 2010, I know there is 250 rows of data related to vessels V11, 81 rows of data related to V12. Okay, and I also can have this in terms of chart. I use pie chart, for example, here. Select vessels. By option, I go for increasing volume. It will start from the larger portion to smaller portion. And labels, okay, at the slice labels tab, I go for frequency and the percent. And to make better in terms of visualization, I click on this draw a line from level to slice. And definitely by variables, I need to set year here. And for a better display, I select on spread graph, click OK and OK. So this is another option where I can actually know in every single year what are the vessels involved and the percentage. Okay. So another tools that I can use to answer this first question is basically I can use the Pareto chart. All right. So vessels in the defect or attribute data box by variable, this is by year. And I select one group per graph independent in orders of bar. So it will start from the from the taller bar down to the shorter bar. Do not combine. Once I click OK, so I will have the Pareto chart based on year Okay, for example, 2010, okay, I have 250 coming from vessel V11, 81, V12, and if I scroll down further, I can have another Pareto chart for the year 2011 and so on. So this is the first task, okay? All right. So the second task is basically for me to determine the total and average of distance coverage and also average of actual speed by each vessel in the specific year. So this is more on descriptive statistic. So in this case, I use the basic statistic, display descriptive statistic. So variable, I can put both. Okay, by variable, this is vessel and year. Okay, I go for the average first or the mean. And definitely I can add on a graph, all right, to make it even attractive, okay, and to have more insight, all right. So for example, in this case, we will calculate the average speed and average distance in the year 2010 for V11 and the histogram at the below. If I scroll down further, I can get another histogram on the distance for V11 for 2010, and then we got for the V12, okay, for this vessel V12. So meaning that we calculate the average, the speed in 2010 and 2011. The same thing goes to the average distance. So this is how, okay, we can have all those information very fast, okay. And at the same time, also I also need to focus only at the vessel distance, okay, and this time I need to go for the total distance for all the vessels in the specific year. So again, I will get the same, all right. In this case, the total coverage distance in 2010 for V11 and also for another vessels V12, for example, in 2010 and 2011. Okay, so that is the completed task, okay, for number 2. And for the next one is involving the inferential statistic, okay, because I want to prove whether or not the vessels covering the same distance average and the speed average, okay. So for this purpose, definitely I will be using one-way ANOVA because I have more than 2 vessels, okay. But before I can proceed with one-way ANOVA, I need to check on the normality. So I can use graphical summary and also can use normality test, but for multiple variables, I usually prefer to use this probability plot because this probability plot also can calculate the p-value and it can display all those p-values in one graph. Okay, example, in this case, graph variables, speed and also distance, okay, by vessel. Okay, multiple graph, okay, on a separate graph. Okay, click OK and click OK. Then I will get exactly 2 graphs. One is on the vessel speed and lower is on the vessel distance. And if you can see, this all the p-value for each vessels in terms of the speed and also all the p-value for each vessel in terms of the distance. So easier for me to know or to determine the normality just by referring to one particular graph. Okay, so since all the p-values more than 0.05 for every vessels in terms of the distance and also in terms of the speed, now before I can proceed with one-way ANOVA, another thing that I would like to check is on the variation of the speed and the variation of the distance for each vessels. Are they the same or not? Okay, I can actually use stat ANOVA, test for equal variance, and then go for one way. But in this video, I would like to share on the assistant, okay, because assistant here give more information in terms of the reporting. So this is where I select hypothesis test. Okay, let me go first for the standard deviation test, which is equal to the test for equal variance. Okay, so in this case, I select the Y data in one column because it is stacking mode. So go for the vessel speed first. The X column represent the factor, which is the vessel. Click OK. So the p-value calculated is more than 0.05 here. So it means that there is no difference in terms of the variation for vessel speed. Okay. So if I want to do the same thing for the vessel distance, I just Control E, which is a shortcut key to recall back the last tools or the last command. So this is where I need to replace vessel speed with vessel distance. Click OK and get the same. Alright, the p-value is more than 0.05, so there is no difference in terms of variation of distance by each of the vessel. And if I scroll down a little bit further, okay, I get more and more reports, okay, by using this assistant tools, which is nicer, okay, for reporting purposes. Right, okay. And now I need to go for the one-way ANOVA, okay, hypothesis test. This is where I need to select one-way ANOVA and change the data orientation for the stacking of the data. Y is a vessel speed, okay, vessel in X value column. Click OK. All right, so in this case, the average of speed by vessels is not the same since the p-value is less than 0.05, okay? So if I want to repeat the same thing for the distance, this is where I replace the vessel speed with the distance, click OK, and I can get the same result here. So in terms of the average distance and average speed, there is not the same, okay, among all the vessels. All right, so this is to answer the third question. And the last is to check whether the speed, the actual speed, is it in control or out of control based on the specific average and based on the specific standard deviation. So this is where I use SPC. Okay. All right. So I go for the vessel speed. Okay. IMR option at the parameter, key in the average of 19, standard deviation of 2, stages by vessel. All right. And click OK and OK. Then I will get the result. So in this case, it's in control, meaning to say that when the captain operate the vessels, okay, the speed, the actual speed is within the given or within the specific average and the specific standard deviation. All right. So this is how a set of tools can be used, all right, to fulfill the objective for a huge amount of data, and it takes less than perhaps 10 minutes. Okay. If let's say the same kind of analytics is required, okay, with a new set of data, so I can have that even faster, okay, when I run a macro on this, okay. All right, for example, just want to demo it, okay, I will get the same result, okay, even less than 15 seconds, okay. So this is the good thing about statistics, give you insight, give you more understanding on the data. So that's all. Thank you for watching.